Alrighty, so we're going to find the volume of a figure that is created when the region bound by the function y equals x plus 1, y equals 3, and the vertical line x equals 0 is revolved about the x-axis. So we know that we're either going to use disk method or washer method, but until we sketch it, we're not really sure which one. So let's see what this is going to look like. Okay, so we know that y equals x plus 1. Let's just 1, 2, 3, 4. 1, 2, 3, 4. All right. So y equals x plus 1 is a linear function that a line that's been translated up 1 unit from the origin. So y-intercept's at 1, and it has a slope of 1, so over 1, up 1, over 1, up 1, over 1, up 1, as such. Okay, that's y equals x plus 1. X equals 0 is the y-axis. And y equals 3 is a horizontal line at 3, 1, 2, 3. So it is this region here rotated about the x-axis. So you can see that none of the region is touching the x-axis. Hence, it's going to be the washer method. Okay? And let's make a little sketch of what this is going to look like. So it's here, and here, and here. So it's basically going to be like this. And you can see what's happening is we have like a cylinder with like a Rollo looking thingy bored out of it. So we're going to be using the washer method, which is A to B. Those are our limits of integration, our starting point and our end point on the x-axis. Okay, and it's going to be outer minus inner. Okay, dx. So our outer radius, let me back up just a bit, and we know that these cross sections are going to be washers. Okay, a washer is a circle with a circle cut out of it, basically. So it's going to be pi big R squared, the radius of the larger outer shell, the larger circle, minus pi little r squared, the radius of the bored out part of it, basically. So look at this right here. We can see that our big R is going to be given by y equals 3. Okay, it's going to be y equals 3. The little r is going to be given by the function y equals x plus 1. Okay, so we're going to go from now to figure out where we're going on the x-axis, because we're going from 0, obviously. But what is this value right here in regards to the x-axis? It's not 3, that's the y value. We have to look at what it is to the x value. Now, if you graph this correctly, you can see that it is at 2. It's going to be at 2. If you're having confusion seeing that, what you do is you take these two functions, y equals x plus 1, y equals 3, set them equal to each other. I'm sorry, x plus 1 equals 3. And you solve for x, and you see that's 2. When you set them equal to each other, you find the x value where they intersect. So that's going to be from 0 to 2. And we know we're going to factor out that pi out front. Our big radius is going to be 3, so it's 3 squared, minus, and our little radius, little r, is going to be the function x plus 1. Okay, and this is going to simplify out to be 9 minus, now remember, x plus 1 squared is the same as x plus 1 times x plus 1. You can't simply just square x and then square 1 and that just be it. It'd be much easier that way, but of course, that just doesn't work. It'd be much easier if the answer to every single math question was 4, but that is not true. So we have to FOIL this out, and we get x squared plus 2x plus 1. So it's going to be, you have to put that in the parentheses because this negative is going to distribute to each one of these. Okay, so x plus 1 quantity squared is x squared plus 2x plus 1. And this is going to simplify out to 9 minus x squared minus 2x minus 1. So what we're going to be finding the antiderivative of, 0 to 2, is going to be negative x squared minus 2x plus 8. Okay, so negative x squared minus 2x plus 8. Now I'm going to erase all this just so we can have some room. You can always rewind the video if you need to look at that a little bit more. Alrighty. So now what we're going to do is we're going to take the antiderivative. And so it's going to be pi times negative 1/3 x cubed minus x squared. New exponent goes to the denominator, coefficient goes to the top, plus 8x from 0 to 2, which simplifies out to be pi times negative 1/3 x cubed minus x squared plus 8x. Now we're going to substitute in our values. Substitute in the 2. So negative 1/3 2 cubed minus 2 squared plus 8 times 2. And once again, 0 as a limit of integration is super awesome because it just becomes 0. Oh, happy day. All right. And so this is going to simplify to be 2 cubed is 8. So negative 8/3 minus 4 plus 16 is going to be pi times negative 8/3 plus 12. And we have to have a common denominator of 3. So negative 8/3 plus 36/3. That's what 12 is equivalent to. And so you get 28/3 pi units cubed. Okay. Okay, so now what we're going to do is we're going to find the volume of the solid found by revolving the region bounded by y equals 2x, x equals 1, x equals 3, and y equals 0 about the x-axis. So let's first off let's determine if we're going to be using the disk method or the washer method. So let's make a little sketch of this, shall we? And let's go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. All right, so this first one's a linear function with a slope of 2, so up 2 over 1, up 2 over 1, up 2 over 1, as such. That's our line y equals 2x. X equals 1 is a vertical line at 1. X equals 3 is a vertical line at 3. And y equals 0 is our x-axis. So it is this region here. And we're rotating this about the x-axis. So it's going to look like this. It's basically going to be this Rollo-looking thingy. Okay? And since the entire region that we rotated about the x-axis is touching the x-axis, it's going to be the disk method. Okay? Since this whole region was touching the x-axis, it's going to be the disk method, which is from A to B, and it's going to be the area of the disk, or the circle, which is the cross-section. Because remember, the disk has an infinitely thin width, so all we have to worry about is the area, and the integral takes care of adding up all the infinite number of those disks. Okay? And that's simply going to be pi r squared. Okay? So our radius is going to be, for each one of our circles, it's given by the function y equals 2x. All right. And we're going from 1 to 3. It's the starting point and end point in respect to the x-axis. So our specific integral we're solving for is from, we can bring the pi out front like before, like I said. We're going from 1 to 3. And our radius is 2x. So that's going to be 2x quantity squared dx, which ends up being pi from 1 to 3 of 4x squared. And what's sweet, we have this coefficient, this constant of 4 inside the integral, so we can bring that out, make it a little bit easier on ourselves. So you end up with 4 pi from 1 to 3 of x squared dx. Now we're going to take the antiderivative. And the antiderivative of x squared is, of course, 1/3 x cubed. And we're going from 1 to 3. Now, right, once again, we have a constant right here, this coefficient, 1/3. So we can bring that out front so that we end up with 4/3 pi and x cubed. We're going from 1 to 3. So we just have to worry about the x cubed of plugging in 3 and 1. So it's going to be, still have this 4/3 pi out front. So it's going to be 3 cubed minus 1 cubed, which is 4 pi over 3, which is, 27 minus 1. So you get 4 pi over 3 times 26, which is going to be 104 pi over 3 units cubed. Awesome. Okay, let's do one more example. So this one's bound by y equals x squared and y equals x. And I'm going to go ahead and make this zoomed in so we can see what's going on. Y equals x squared, quadratic parent function, which looks as such. And y equals x is a linear function, which looks as such. And we're revolving this about the x-axis. So you can see it's going to look like this. This kind of strange looking little thing. And it's going to go like this. And you can see from the drawing that it is indeed going to be a washer, because you can see that we have an outer shell and an intersection bored out. Also, you can tell also because the region is not wholly touching the x-axis. Anytime it's not touching the x-axis, the region completely touching the x-axis, you know it's going to be a washer. So it's going to be outer minus inner, which is pi big R squared minus pi little r squared. And so our radius, our big radius, the outer radius, is going to be given by y equals x. Okay, that's going to be our big R. The little r is going to be given by the function y equals x squared. Okay, that's going to be little r. So therefore, it's going to be, and we're going from 0 to 1. You can just tell that from the graph. I can bring this pi out front. So it's going to be big R squared, which is going to be x squared minus little r squared, which is x squared, squared dx. So we're going to be finding from 0 to 1 of x squared minus x to the 4th dx. So now we take the antiderivative, and you get 1/3 x cubed minus 1/5 x to the 5th from 0 to 1. So we substitute in 1 for x, 1 cubed. I'm sorry, yes. 1 cubed minus 1/5, 1 to the 5th, minus, once again, 0 is a limit of integration, totally rocks. So you end up with 1/3 minus 1/5. And let's get a common denominator there of 15. So we get 5/15 minus 3/15. So our answer is 2 pi over 15 units cubed. And that'll do it for our review. Have a good one, guys. We'll see you soon.